Alright guys, so today's notes are slightly a little bit different than what we've been doing in the past. It's got a lot of worked out examples for you. There are exactly 4. So that way, if you get stuck at home, you can try to refer back to those because it tells you step by step what to do. If not, again, if you're watching this video for extra help, I'm just going to briefly go over these so that way we can get to the hands-on working through examples. So today I'm going to multiply some radicals. These radicals are going to get multiplied with whole numbers or constants and other radicals. So first steps first is taking a look at example number 1. I have the square root of 3 times 7 minus the square root of 8. So what we're going to do is we're going to distribute that square root of 3 first. So just as if I were using 3 times 7 minus, oops, that's supposed to be minus 9. My fingers are getting ahead of my head. The same thing as if I was saying 3 times 7 minus x. I distribute that 3 to everything. I'm going to use that kind of as my example here to follow along with. Next, I'm going to go ahead and take a look at the product. So if you notice, my 7, let's do it the, oops, wrong thing. My square root of 3 and my 7 are not the same thing. It's like saying 3 times x, which is kind of what I have over here. So my example is a little bit backwards. Well, my 7 does not have a radical, so I don't get to magically create one with it. Just like my 3 doesn't magically have an x. I just stick them together with my number first. Number being my regular constant. Same idea over here. My 7 and my 3 are not the same type of number, so I'm going to write my 7 with that square root of 3. So this first part here is like the second part on my example. Likewise, since my root 3 and my root 8 are the same, I can multiply them underneath my square root. Since my 3 and the 7 are constants, I can just multiply to get them together. I don't have to just stick them together. So I'm going to leave that multiplication there for a second. Okay, now I'm going to actually go ahead and multiply that through. So 3 times 7 gives me 21. That 3x follows with. 3 times 8 is 24, and it stays under that radical. Well, you're probably like, well, I can simplify the square root of 24. I can simplify that square root of 24, can't I? Yeah, 24 is equal to 4 and 6. 4 is 2 times 2. Group comes out. 6 we know is 2 and 3. Nothing comes out. So then I can simplify it by saying it is square roots. Ignore that step. I don't like this one. Square root of 4 is 2. 6 stays with. I ask myself, do I have the same number underneath my radical sign? Nope. So I have to leave it alone. A little bit more intensive than my off to the hand side example, but same kind of idea. Let's take a look at this second one. Again, I know you can see it on your paper. I want to go through it so each line makes sense. So in this case, it's like saying x times x plus x squared. I'm going to distribute that to x to everything. Since they're the same, I can go ahead and start doing the multiplication underneath the square root because I have this 2 square root 2 here, and 2 square roots here. When I actually go ahead and multiply those together, I get 16 and 36. Then I ask myself, is 16 perfect? Is 36 perfect? They both are. So I end up getting 4 plus 6, which gives me a nice answer of 10. 10 is a little bit easier. So yes, I multiplied by both radicals, but I got a nice whole answer. Okay, same kind of idea. I'm going to distribute through that square root of 6. We know that when I multiply my 6 with my 3, it's not the same thing, so I'm just going to go ahead and put that square root of 6 behind it as if it were a variable. Again, I have 2 radicals, so I can go ahead and bring in the other one and multiply them underneath that square root, which gives me 48. Then I ask myself, can I simplify that 48? And lo and behold, I can. I can get 16 times 3. And I don't really like that step. When you talk this one out, the square root of 16 is 4. Square root of 3 stays alone. I have my 3 square root 6. I ask myself, can I simplify those? Nope, 2 different answers, 2 different variables, 2 different numbers underneath, so I cannot simplify. All right, this one's a little bit more intensive. The reason I say that is I have a number out front now. So I'm going to treat this exactly the same way as I've done the other ones. If they have square roots, I'm going to multiply the numbers underneath together. If not, I'm going to stick the number with the coefficient. So first things first is I distribute that square root of 5. I can multiply these through. I can multiply my 5 and my root 3. That's how I get that 15. Again, 10 times 5 is 50. So I asked myself, can I reduce any of these? Well, square root of 50 quarters, so 2 and 25. Square root of 25 is 5. That square root of 2 cannot be simplified. So I have square root of 2, square root of 15. Do I have the same number here? Nope. So that's my final answer. All right. Let's go ahead and work some of these through together. So step number 1, we're going to distribute. I have square root times square root, which means I'm going to have the square root of 7 times 7. Again, I have square root times square root, so I have minus 7 times 3. Notice I'm kind of doing that all in one step. Seeing those first 4, I'm hoping we can kind of recognize we can start doing those. We don't have to do all of those steps out. All right, 7 times 7 gives me 49. So I have the square root of 49. 7 times 3 gives me 21. 49 is perfect. It's 7. 21. Can anything go into 21? Well, yeah, we just saw the step above, 7 and 3. Neither of those can be broken down anymore, so my final answer is 7 minus the square root of 21. All right. Square root and square root, so we're good. I'm going to do that again. So I'm going to have the square root of 5x times x gives me 5x times x gives me squared. It's like saying 5 times 1 because there's an invisible 1 out there. X times x, I add those exponents of 1 together to get 2. Then I'm going to multiply that to the second one. Now that 3 is on the outside, so it's going to stay on the outside until I can simplify something and maybe bring it out with it. I can multiply my 5x together with my, I can multiply my 5x together with my 5. 5 times 5 gives me 25. That x just follows with for the ride. I have no other x's. I'm not magically going to get an x squared in that term. So simplifying this first term, I cannot take the square root of 5, but I can take the square root of x squared. I have a group of 2. 2 divided by 2 is 1, so I can bring out an x. I'm left with 5 underneath. 3 is still there. We haven't reduced it yet. We haven't done anything with it. I can take the square root of 25 and get 5, so my 5 is going to come out. I do not have enough x's, so my x has to stay under. 3 times 5 is 15. And I ask myself, do I have the same number under the radical sign? I do not. So that is my final answer. Let's do a couple of these together. A couple of these will be on your own. First steps first. I want to try and reduce it if I can. If you notice, we couldn't really reduce any of these multiplications. However, what's the square root of 4 in this first example? 2. Square root of 25. 5. 2 times 5 is? Whoop. 10. All right. Sweet. So the second example over here, I'm jumping to the right. I have that 3 on the outside. On the inside, I'm going to take 6 times 8. Excuse me, 48. X times x, which gives me x squared. Okay. All right, so I asked myself, can 48 be broken down into anything? 16 and 3. We're kind of seeing a pattern. We've seen this number a couple times. There's my group of 4. So I have that 3 times that 4 that comes out. Square root of 3 hangs around inside. Take a look at my x squareds. Can divide out 2, so 1 comes out. So my answer here is 12x square root 3. So that one was a little bit more intensive. All right, this third one. Oops, that's the same color. I don't want that. My bad. We like colors for a reason. Okay, third one. I cannot reduce the square root of 3, but can I take the cube root of 27? If you're shaking your head no, please look at your chart. You can. Your answer is 3. So now I have the square root of 3 times 3. Well, they're not the same, so I can just stick them together with my constant first, followed by my square root. I want you to do the next one. I'll help you get it started. 2 plus square root of 5 is the same thing as saying 2 plus square root of 5 times 2 square root of 5. Or not, maybe. Thank you. Let me go back. Ta-da. Okay, so I can pretend that square term doesn't exist as long as I can multiply those together. So, hint, hint, we're going to FOIL. Woo! Oops, wrong button. So, pause it up, go ahead and FOIL. Alright, foiling first times first. 2 times 2 is 4. 2 times square root of 5 is 2 root 5. 2 times root 5 is 2 root 5. And root 5 times root 5 is the square root of 5 times 5, which is 25. So that gives me 4. I have the same thing here, so that gives me 4 root 5. Square root of 25 is 5. I can take 5 plus 4, which gives me 9. Cannot reduce that square root of 5 any longer. So my answer is 9 plus 4 root 5. Again, the next problem, I could start out by multiplying, but I find it easier to simplify because then I can potentially work with smaller numbers under my square root. I don't want to have to deal with large numbers and I'm just like, well, I have no idea what goes in that. So I find it easier to start by simplifying. So I get 9 and 2. 9 is 3 times 3. 50 is 25 and 2. 25 is 5 and 5. So I've got my groups. Oops. So I get 3 root 2 times 5 root 2. I'm going to multiply my 3 times my 5, which gives me 15. Going to multiply my 2 times my 2 because it's the same thing, which gives me 4. Square root of 4 is 2. So I get 15 times 2, which gives me 30. Now, would you have known that when you multiply 18 times 50, which is 900, the square root of 900 is going to be 30? Some of you might be able to guess that based on other properties of stuff, but my assumption is the majority of you will not. So I find it easier to first, stop highlighting things. I find it easier to first simplify when I can. Last one, root 5 times root 10. Neither of those can really simplify down. So multiply through and get 50. 50 is 25 and 2. Square root of 25 is 5 and 5. Hey, look, there's my buddies. So I get 5 root 2. All right, so that's all we got. Thanks for watching.